Section 4.2, the mean value theorem. First of all, let's start with the Rolle's theorem. Suppose that you have a function f of x which is continuous at every point of the closed interval ab, and that function is also differentiable at every point of its interior value, from a to b. If, and this is the situation for Rolle's theorem, condition for Rolle's theorem, the value of the function at endpoints are equal, then there is at least one number c in an open interval ab at which the derivative of the function at that point would be 0. So think about this. Let's say you have defined a differentiable function from a to b, and then we know it's a coordinate system. So let's say there is a coordinate system, and a and b are some positive number, but it doesn't matter whether they are positive or negative. And we know that the value of this function f of x at a and b, they are equal. Equal means the value should be same. Okay, now because it's a continuous function, you have to somehow join this point to this point. Let's say you just go somewhere like this, come back like this. So because the value of the function at this point a and b are equal, for somehow after going up or down, it has to go back to this value and connect with that. So by doing that, what happens is, if you look at here at point, let's say this C point, if you try to draw the tangent line here, that is actually the horizontal tangent line. Even here, that is actually the horizontal tangent line, meaning the derivative of the function at this point, let's say C, is 0. At least one number has to be like this. You might have more than one number, but at least if you go up or down, somehow you have to connect with these 2 points, and that is only possible by getting this local maximum or local minimum value of the function, and at that point the derivative would be 0. So that's the explanation. More graphs like this, the value of the function at a and b are equal, so somehow you have to join them, and by doing that you will be able to see this kind of points where the slope of the tangent line, or there will be horizontal tangent line, and because of that the derivative at that point would be 0. There are so many points like this here in this second graph, so but at least you must have at least one point like that. Okay, sometime for example, these are the 3 graphs where that situation you don't see the derivative 0, because there may be no horizontal tangent line, because they do not satisfy hypothesis of Rolle's theorem. For example, the first one, you can see that this is a discontinuous function at a, there is a jump. This is discontinuous function at x0, so it has to be continuous function, and it has to be a differentiable function in the interior open interval from a to b. But at this point x0, you can see that this is not differentiable, because none of this graph would satisfy the Rolle's theorem. So you will not be able to see horizontal tangent line, meaning the derivative is not 0, okay, for this graph. So there is one more theorem that's called mean value theorem. That's the main name of this section. Mean value theorem says, if you have a continuous function f of x which is defined on closed interval, that function is a differentiable function inside that closed interval, then there should be one point, at least one point in that interval, the open interval ab, such that the derivative of function is equal to this value. This is actually, so let's say this is the continuous function, here is a, here is a b, let's say these are the a and b points. So at a, the value of the function is f of a, at b the value of the function is f of b. This means it's the slope of the second line joining these 2 points, let's say a and b. If you try to find the slope of this second line joining this a and b, it will be f of b minus f of a over b minus a. So the meaning of this mean value theorem is, if you have continuous function and differentiable function which is defined on closed interval ab, then there should be at least one point inside this interval, such that if you try to draw the tangent line at that point, that slope of that tangent line would be equal to the slope of this secant line, because slope of this tangent line at C is the derivative of the function at C. So that is the meaning of this mean value theorem. So this is the geometrical interpretation of the mean value theorem. There are 2 points A and B, and if you try to find out the slope of that secant line, that would be the slope. Then there must be one point C inside A and B, such that, if you draw the tangent line at that point, the slope of that tangent line should be equal to the slope of the secant line. So there are some corollary that comes from, we can prove this statement by using the mean value theorem, but these are easy to understand. So I'm going to explain you why it happens. So for first one, if the rate of change of any function is 0 everywhere in that open interval, the meaning that is only possible if the function is constant function, because rate of change of 0 means no change. No change means the function has to be constant. The second one, if you have two functions whose derivative are equal, meaning the rate of change of the first function is equal to the rate of change of the second function, that is only possible if first function and then second function, they are differ by some constant. Okay, for example, let's say f of x is x squared, g of x is x squared plus 5. When we try to find out the derivative of the first function, it's a 2x. The derivative of the second function, it is also 2x, because derivative of constant is 0. So the rate of change of two different functions are only equal if they are only differ by some constant. These are some properties of exponential function or laws of exponential function. Now let's look at some examples. The first example is, find the value or values of C. There might be just one value or more than one value, such that this thing is possible. Okay, and we have given a function, we have given the interval, the value of A and B. We just need to find C. So for that, what we need to do is, we need to find out the value of the function at A, which is f of 1. Plug the value of x is equal to 1 here, that would be 0. We need to find out the value of the function at B, which is f of 4. Plug the x equal to 4 here, it will give you square root of 3. And now find the value of derivative of this function, which is 1 over 2 times square root of x minus 1. That's the derivative of this function by using the power rule. And now, according to this statement, we just have to plug the value of f of b minus f of a over b minus a equal f prime of c. So you can just replace this x by c, and you can just write it down 1 over 2 times c minus 1. So we're going to plug this value back here. So f of b is square root of 3, f of 1 is 0, over b minus 1, which is 4 minus 1, equal f prime of c, which is 1 over 2 times the square root of c minus 1. Just do the cross multiplication and try to solve for c. If I do the cross multiplication, before that I have to simplify this. If I do the cross multiplication, I'm going to get square root of c minus 1 equal square root of 3 over 2, and just square both sides. That will give you c minus 1 equal 3 over 4, and that will help us to find the value of c, which is 1 plus 3 over 4, which is 7 over 4. 7 over 4 means it's a greater than 1, less than 2, which is from here on this interval. So that means there is a value of c inside this interval, which is 7 over 4, such that the derivative of the function at that point is equal to this value. So the answer is 7 over 4. So that the function f of x equal x to the power 4 plus 5x plus 1 has exactly 1 0 in the interval -1 to 0. First of all, make sure that this is a polynomial function. Polynomial means it's a continuous function and it's a differentiable function. And if you try to find out the value of this function at endpoints, let's say -1, at -1, the value of this function, if you try to find out at -1, it would be 1 minus 5 plus 1, which is it's a negative, because it's a -3, less than 0. At 0, 0 plus 0 plus 1, just plug x equal to 0 here, it will be positive. So at the endpoints, from -1 to 0, the value of the function is negative here, the value of the function is positive here. So somehow you have to connect them because this is continuous function, so somehow you have to join them. By joining them you will be able to see 1 0, at least 1 0 here, right? But what this problem is asking us to do is so that the function has exactly 1 0. So we see that there is exactly 1 0. Now by using, this is called intermediate value theorem, meaning if at one point it's a negative and at other point if it's positive, then there has to be 1 0, and that comes from intermediate value theorem. So that's done, there is nothing you need to prove here. But now there is 1 0 for sure, but how do we prove that there is exactly 1 0? There might be more than 1 0. So what we do, we start doing by opposite. So for example, let's say if possible, so from here we can say that we can say by using intermediate value theorem, theorem intermediate value theorem, there must be at least 1 0, on -1 to 0. So 1 0 means where the value of the function is 0, and that is possible because intermediate value theorem says if on this interval at one point the value is negative and other point the value is positive, and if the function is continuous, there has to be 1 0. Now we know that there is at least 1 0, but we need to prove that there is exactly 1 0. So what do? We just say, okay, let's assume that there are 2 zeros if it's possible. So I'm going to just add one extra page here. If it's possible, let's say there are 2 zeros. Let's say if possible there are 2 zeros at x equal to a and x equal to b, meaning the value of the function at a is 0 and the value of the function at b is 0. We don't know what is a and b, so we are going to find it out if it's possible. But as you can see that the value of the function at a and b, some point a and b, both of them are 0. Okay, so we can go back and use the Rolle's theorem here. As you can see that if the value of the function at one point to another point, if they are equal, then there must be at least one point where the derivative of the function should be 0. So these are the 2 points a and b, and they are from in between in 1 to 4, because no, not 1 to 4, it's -1 to 0. So it's a -1 to 0. So from -1 to 0 there are 2 values where the value of the function is 0, but by using the Rolle's theorem, if that is possible, then the derivative of the function must be equal to 0 at one point in between here. So let's find out the derivative of this function, which is 4x cubed plus 5. So according to the Rolle's theorem, because there are 2 points where the value of the function is 0 on this interval, then according to the Rolle's theorem, this derivative, there should be one point in between these 2 points such that the derivative of function should be 0. So let's try to solve this one, which is 4x cubed plus 5 equals 0. And if you try to solve for x, that gives you x equal cube root of -5/4. But this is less than -1. This is to the left side of -1. It's not from actually, point from -1 to 0. So that is the contradiction. So we did not find anything from -1 to 0 because this value is less than -1. So that false statement, that false result we got because of this assumption. We assume that the value of the function, at 2 different points are 0. That assumption was wrong. So what we can say now is there is exactly 1 0, no more than 1 0. We already knew that by intermediate value theorem there is at least 1 0. Now by doing this we can say that, oh, there is exactly 1 0, there is no more than 1 0, because if there is more than 1 0, then it gives us the contradiction here. Okay, find all possible function with the given derivative. So derivative is given, so now we need to think about those function whose derivative is the first function and then second function. And also keep in mind there are two functions whose derivative are equal if those functions are differ by some constant. So first of all, find out the function whose derivative is sine 2t. So we know that the derivative of cosine 2t is negative sine 2t times 2. So if you try to find out the derivative of negative cosine 2t over 2, if you try to find out the derivative of this thing, it will be negative sine 2t times 2, which is eventually sine 2t. So the derivative of negative cosine 2t over 2 is sine 2t. Okay, so we found the function for this one. Similarly, the derivative of cosine t over 3, no, the derivative of function was, now we need to find out the function whose derivative is cosine t over 3. We know that the derivative of sine is cosine, so there must be sine t over 3. But if you try to find out the derivative of t over 3, there would be 1/3 available. So I'm going to find out the derivative of this whole thing. By doing that, it will give me the derivative of sine t over t over 3 is cosine t over 3 times derivative of t over 3 is 1/3. And if I cancel this, it's going to give me cosine t over 3. So I know from here the derivative of 3 sine t over 3 is cosine t over 3. So we are looking for the function whose derivative is sine 2t plus cosine t over 3. So the answer would be, the function is this one sine 2t plus this one cosine, sorry, that's my bad. Okay, the function would be this one and this one. Okay, so let me just erase this here. Okay, so function would be this one, which is negative cosine 2t over t 2 plus 3 sine t over 3. So this, if you try to find out the derivative of this function, that will be this one. But that is not everything. You might have function this thing plus some constant, maybe some constant. That's why we have to use this statement here. So after finding those value, you have to add some constant too. So this is the final answer. The function, because there are more, infinite function. If you add any constant, the derivative of that function and the derivative of this thing would be the very same thing here. So the answer is f of t would be negative cosine 2t over 2 plus 3 sine t over 3 plus some constant. Okay, because they are asking us all possible functions, so there are infinite possibility. Okay, suppose that a drop of mist is a perfect sphere and that through condensation the drop picks up moisture at a rate proportional to its surface area, so that under this circumstance the drop's radius increases at a constant rate. So this is what you have to summarize. There is a sphere that's a drop of mist, and you need some information about the sphere, that is like volume. What is the volume? What is the surface area? You need the formula for that, and you also have to understand about this. The drop picks up moisture at a rate proportional to its surface area. The drop picks up moisture. Here they are talking about the rate of change of the volume of that sphere. Okay, this is about rate of change of the volume of that sphere. So let's look at this one. If you have a sphere with the radius r, then this is the formula for the volume, which is 4 over 3 pi r cube, and this is the formula for surface area. Now this is the drop picks up moisture at a rate proportional to the surface area means it's actually the drop picks up moisture. This one is actually dv over dt. So from the problem statement, dv over dt, that means rate of change of the volume is this is proportional to the surface area of the sphere. So here, if proportional means we need to use some kind of constant. If k is a constant, then this statement means the rate of change of volume with respect to time is constant times the surface area. If this is the information you have given, then we need to find out rate of change of radius. How do we do that? First of all, find out the rate of change of volume by using this formula, meaning just differentiate both sides with respect to time, and that will be 4 over 3 pi 3 times r squared dr over dt. We can cancel this. This is 4 pi r squared dr over dt. So that's the rate of change of volume with respect to time. So let's do that. Let's plug the value of that thing here. 4 pi r squared rate of change of radius with respect to time is equal to k times s. S means it's a 4 over 3 pi, sorry, s means it's a 4 pi r squared. Okay, so s is 4 pi r squared. So let's just try to simplify the thing. There is a 4 pi r squared, there is a 4 pi r squared. So the rate of change of the radius with respect to time is k. So changing rate of the radius is constant k. So that's the answer.